All right, so this is the homework set for the topic of functions and pre-calculus. And so we'll just kind of go through these. These go with the lecture videos or video for introduction to functions. And so it covers kind of evaluating functions and domain. And then this first one looks at net change. So we'll just kind of do these, kind of give a step-by-step solutions for these and kind of the thought process behind how we solve these. So we're given the function f of x equals x cubed plus 1. And we want to find the value of f at x equals -1. So all this means is we're going to plug in -1 for it. So anytime we see an x, which in this case is only 1, well, 2 if you count the input here. Anytime you see an x, you're going to plug in a -1, and then we're going to simplify. So we have f of -1 is -1 to the third plus 1. And now we're just going to simplify this. So we have -1 to the third is -1 plus 1, and that gives us 0. So f of -1 equals 0. And so that's all there is to it. So no matter what this is, whenever you see an x in the function, you're going to plug that number or variable or expression. It could be really anything in for the x. So in this case, part B, we have the value of f at x equals 2. So we're looking for f of 2, and we're going to plug 2 in for each of these x's. So we have f of 2 equals 2 to the third plus 1. So 2 to the third is 8, and then plus 1, and we get 9. So f of 2 equals 9. All right, and then part C, we have, we're looking for the net change in the value of f between x equals -1 and x equals 2. So how much, essentially what this is asking, how much is the y changing over that interval of x's? So a function takes an input and gives an output. So if we look at these two inputs, and we're going to figure out the difference. How much did it change over that interval? So this would be f of 2 minus f of -1. And so that's just what we found in parts A and B. So f of 2 is 9 for part B. And then f of -1 is going to be 0. So this is just 9 minus 0, which of course is 9. All right, so there is the first one. Let's look at number 2 here. So number 2, complete the table. We have g of x equals absolute value of 6x plus 1. And so we have a table of inputs here. So the x, of course, is always going to be our input. And then the g of x or f of x or h of x or whatever the function is, that will be our output. And so now all we need to do is plug in each of these x's or each of these numbers in for the x, and we can get the output. So g of -3 would be the absolute value of 6x or 6 times -3 plus 1. And just simplify that. So 6 times -3 is -18 plus 1. -18 plus 1 is -17. And of course, absolute value of -17 is 17. All right, so g of -3 would be 17. G of -2, absolute value of 6. Just plug in -2 for the x, plus 1. We get -12 plus 1. And that gives us absolute value of -11, which of course is 11. So g of -2 is 11. G of 0 would be the absolute value of 6 times 0 plus 1. 6 times 0, of course, is 0. 0 plus 1, it's going to be the absolute value of 1, and that is 1. And then g of 1, we have absolute value of 6 times 1 plus 1. So that would be absolute value of 6 plus 1. We'll go ahead and write 7, and then absolute value of 7 is 7. And then g of 3 we have absolute value of 6 times 3 plus 1. And so that would give us 18 plus 1, which is absolute value of 19, which of course is 19. So G of 3 is 19. And of course, notice all these are positive. We would expect that because all of these are absolute value. Absolute value is always positive. So just something to keep in mind while you're doing these. Kind of think about what the answer should look like. Of course, you should never get a negative number if you're just taking absolute value. All right, evaluate the function at the indicated values, so more of the same. So we're going to plug in 4 for the x, so 1 minus 4 times 4 over 15. We get 1 minus 16 over 15. 1 minus 16 is negative 15 over 15, and that gives us negative 1. So f of 4 equals negative 1. Plug in negative 4, we get 1 minus 4 times negative 4 over 15. That gives us 1 plus 16 now. So you have the negative 4 times negative 4 gives us plus 16 over 15, and that is 17 over 15. And not going to can't simplify that anymore. Then, then we get f of 1/4, and let's write the function here. So we have reference 4x of 15. So here we have 1 minus 4 times 1/4 over 15. Negative 4 times 1/4, that would give us a minus 1. So 1 minus 1 over 15, that gives us a 0 over 15. And then 0 divided by any non-zero number, of course, is going to be 0. F of a, so now this is where, think about what does this mean? So this is the input. We're going to input this into the function. And so just like we did for these last several, really, all the previous ones that we've done so far, we are plugging in whatever is in the parentheses, we plug that in for the x and simplify, which so far we've been able to simplify. But if we plug in a for x, then we just get 1 minus 4a over 15. And there's really not anything to do with that. We can't really simplify that anymore. But that's all you do. So anywhere that there's an x, in this case by the 4 times x, plug a in for that, and then that is what f of a is. F of negative a, so again, we're going to plug in negative a for x. And now this time we can simplify this a little bit. So we can have negative 4 times negative a, and that'll give us a 1 plus 4a over 15. So it doesn't matter what is in the parentheses here. Whatever is in the parentheses, you plug in for the x. And in this case, you're going to, whatever that is, you're going to multiply 4 times that, and then you're going to do 1 minus whatever you got there, and then divide by 15. So it's always the same for this function. So in this case, we have a minus 1. So we are going to plug in a minus 1 for the x. So we have 1 minus 4, and then a minus 1. Now this part is where a lot of people will kind of mess up. You don't want to do this where you say 4a minus 1, because this is not the same as that. You need the parentheses around. So don't do that where you don't put parentheses, because 4 is multiplied, whatever the input is, 4 is multiplying by that whole thing. If you don't put the parentheses, now it's just 4 times a, and now you have this minus 1 over here that's not being multiplied by the 4. So you need the parentheses. So now we can distribute the 4. So you have 1 minus 4a, and then negative 4 times negative 1. That'll give us a plus 4 over 15. And so 1 plus 4 is a 5. 5 minus 4a over 15. And then, of course, you cannot cancel the 5 and the 15. You can't factor out a 5 and then cancel out the 5s. That would only work if this one was also a multiple of 5. And then if this is a multiple of 5, you could factor out the 5 and then cancel it with the 5 times 3, which is 15. So don't cancel things that are attached by addition or subtraction. It doesn't work that way. But at least for this problem and these problems that we've been looking at, anytime anything that's in the parentheses, plug that in for the x. Anywhere that there's an x, in this case there's only one, but anywhere that there's an x, and then you can simplify from there. All right, moving along, another similar problem. G of x is 1 minus x over 1 plus x. So we're going to evaluate that at 2. So 1 minus 2 over 1 plus 2, that's going to give us negative 1 over 3. G of negative 1, 1 minus negative 1 over 1 minus 1. And now we have 1 plus 1, which is 2, but then on the bottom we have 0. So this one's actually undefined. So you cannot divide by 0. That does not work. Plug in 1/2. So 1 minus 1/2 over 1 plus 1/2. So here we get 1 minus 1/2 is, of course, 1/2. 1 plus 1/2 is 3/2. And so here we have 1/2 divided by 3/2. The 2's will cancel. So they're both in the denominators of their respective fractions. And so we have 1/3. Then G of A, of course, that one would be easy. 1 minus A over 1 plus A. And then A minus 1, we're going to plug in A minus 1. So 1 minus, now again, parentheses. Always use parentheses. If this is more than one term, always use parentheses when you're plugging it in. Especially if there's subtraction or multiplication. Down here, really you don't need it, but it doesn't hurt anything. So now let's distribute the negatives. So we have 1 minus A plus 1. Here we have 1 minus 1. So the ones are going to cancel, and we just have A on the bottom. And again, the A's cannot cancel here because they are attached by addition and subtraction to other terms. And so the cancellation does not work in that case. 1 plus 1 is 2. So we have 2 minus A over A. And there is our answer. All right. Now we have G of x squared minus 1. So 1 minus x, we're going to plug in x squared minus 1 for that x, over 1 plus x, and we're going to plug in x squared minus 1 for that x. And so now we pretty much get the same thing. A and x squared are basically just kind of substituting in for each other there. So 1 minus x squared plus 1, and then on bottom, the 1's are going to cancel out again, and we just have x squared. And then we get 2 minus x squared over x squared. And then there is our answer for that one. So you notice these are the same. We really just changed that one little part. So obviously if it was x cubed, it'd be x cubed. If it was b, we'd just have a b. If it was square root of t, we'd just have square root of t there. So we kind of see in this particular case, now this isn't a rule. It is possible that we could have a function that would do something different maybe. But in this case, just the a and the x squared are kind of doing the same thing as each other. All right, number 5. So here we have a piecewise function. F of x is x squared if x is less than 0, and it is x plus 9 if x is greater than or equal to 0. So now in this case, you have to look at your input and figure out, is it less than 0 or is it greater than or equal to 0? And depending on where it is, depends on where, or dictates where you're going to plug it in. So in this case, -2 is less than 0. So we're going to plug it in up here. So here we have -2 squared. And -2 squared, of course, is 4. F of -1, -1 is less than 0. So we're going to plug it into x squared. And so we have -1 squared, which of course is 1. 0 is greater than or equal to 0. It's equal to 0, obviously. So we're going to plug it into the x plus 9. So we have 0 plus 9, which is 9. F of 1, so 1 is greater than 0. So we have 1 plus 9 equals 10. And see if they have any more. Yep. So 2 is greater than 0. So we're going to plug that one into the x plus 9, and we get 11. Now, in this case, we could not do, say, f of a unless we know what a is. Or at least, is it less than 0 or is it greater than or equal to 0? So in these cases, you can't really do a variable without knowing where the variable would be in relation to wherever this function is split. All right, number 6, another piecewise function. So this one is split at 2. So x is less than or equal to 2. It's going to be equal to 3. And then greater than 2 is going to equal to x minus 6. So f of negative 3. Negative 3 is less than 2. So f of negative 3 is going to equal 3. F of 0, 0 is less than 2. So f of 0 is going to be 3. F of 2, 2 is less than or equal to 2. It's equal to 2. So we're going to be in this top part. So f of 2 is also going to be 3. F of 3, 3 is greater than 2. So it's going to be 2 times 3 minus 6, which of course is going to be 6 minus 6, which is 0. And then last we have f of 5. So 5 is greater than 2. So we have 2 times 5 minus 6, which is 10 minus 6, which is 0. All right, number 7. So now we have a three piecewise function, 3 pieces of the function. So let's look at negative 2. So negative 2 is less than negative 1. So we're going to plug it into x squared plus 2x. So negative 2 squared plus 2 times negative 2. Negative 2 squared is going to be 4. 2 times negative 2 is negative 4. So we have 4 minus 4, which is 0. Negative 3 halves. Negative 3 halves is less than negative 1. So we'll use the top function again. So negative 3 halves squared plus 2 times negative 3 halves. So negative 3 halves squared would be 9/4. 2 times negative 3 halves would be minus 3. And then 9/4 minus 3, we can find a common denominator. So 3, if we make the common denominator 4, that would be 12 over 4. So 9/4 minus 12/4 would be negative 3/4. F of negative 1. So negative 1 is equal to negative 1. So the equal part is on this part. So we're going to use this top function again. So negative 1 squared plus 2 times negative 1. Negative 1 squared is 1 minus 2, and it's going to be negative 1. F of 0. So let's go back up. So 0 is between negative 1 and 1. So we're going to let f of x equal x. So f of 0 is just going to be 0. Then we have f of 15. So 15 is greater than 1. So f of 15 is negative 1. All right. So no matter how many pieces there are, no matter what your x is, you look at where your x is, on any of these pieces, and there's no limit really to how many pieces you could have in a function. But wherever your x lands, that's the piece that you use and evaluate the function using that piece. All right. right, we're evaluating functions. So f of x plus 2. And so here we're getting a little bit more complicated functions. So 2x squared plus 4. So we have 2 times x plus 2 squared plus 4. And so now let's multiply this out. Okay, so it's been a minute since you worked with foiling. So x plus 2 squared is x plus 2 times x plus 2. And of course, there's a formula for this shortcut, but we'll kind of FOIL it out. So we're going to do the first terms, the outer terms, the inner terms, and the last terms. So x times x, we get x squared. X times 2, we get 2x. 2 times x, we get 2x. And then 2 times 2, we get 4. So this simplifies to x squared plus 4x plus 4. So we have 2 times x squared plus 4x plus 4 plus 4. So let's distribute the 2. So 2x squared plus 8x plus 8 plus 4. And then the 8 plus 4 gives us 2x squared plus 8x plus 12. All right, now notice this one is not the same as that. So this one has the inputs split. So we're plugging these into the functions separately, not together. So f of x is 2x squared plus 4. And we'll underline that, and then let's change the color for the next part. We'll use green. So this part is going to be green. Plus, now we're going to plug 2 in for the x. So 2 times 2 squared plus 4. Go back to the blue. 2x squared plus 4. And then plus, so that'd be 2 times 4. It should be 8 plus 4. And then we'll just finish up with the blue. 2x squared, and then we have 4 plus 8 plus 4. So that'd be 4 plus 8 is 12. 12 plus 4 is 16. And so you can see these are not the same. Probably very rarely would be where you have one input and then you split the input between the two functions. There's no real utility to that. It's not something that comes up or anything, but just as an exercise to so you can see the kind of the difference here. All right, number 9. So similar thing. So f of x is 3x minus 6. We're going to plug 2x in for the x. So we have 3 times 2x minus 6. So 3 times 2x is 6, x, and then minus 6. And so there's our f of 2x. Now we have 2 times f of x, which is 3x minus 6. And so now distribute the 2, we get 6x minus 12. So you can see now that pulling the coefficient out does not equal the same thing. So you can't pull the coefficient out. All right, number 10. Actually, let's see if there's any other. Nope. Number 10. Find the net change in the value of f of x equals 7x minus 6 from 1 to 7. So net change from A to B. So whatever x equals A to x equals B, that is just going to be f of B minus f of A. So in this case, we're looking for f of 7. So we're going to let B equal 7 and A is going to equal 1. So let's find f of 7. So 7 times 7 minus 6. So that'd be 49 minus 6, which is 43. And then f of 1 is 7 times 1 minus 6, which is, of course, 7 minus 6, which is 1. And so then net change would be f of 7 minus f of 1, which is 43 minus 1, which of course is 42. So the function, the y value or the output of this function changed, increased by 42 from x equals 1 to x equals 7. All right, number 11, difference quotient. Now, if you're going to take calculus, this is an idea that you need to familiarize yourself with, finding the difference quotient. This has to do with slope, although we won't really get into that here. But this does have to do with the slope. And so let's find f of a. So here's our function. F of x is 1 minus 4x. Let's find f of a. So f of a is 1 minus 4a, f of a plus h. So we're going to plug in a plus h in for the x. We have 1 minus 4 times a plus h. And we could distribute the 4. I think we'll leave it this way for now. It doesn't matter too much, I guess, as far as just the answer to this part. And now let's find this difference quotient. So f of a plus h minus f of a over h. So f of a plus h minus f of a over h. Now, before I do this, remember a minute ago I said difference quotient is kind of a way to think about slope, and it is a slope. It is the slope of this function between the value of x equals a and the value of x equals a plus h. So that distance of h, so the difference between these two values is h. So that difference, what is the slope between those 2 points? So if we had, say, a curve, and we had a point here, and we had a point here, that this will calculate the slope between those 2 points. So with that in mind, this f of x equals 1 minus 4x, you might remember from algebra, what's the slope of that? And the slope is -4, right? So the slope is -4, the y-intercept is 1. So with that in mind, let's do this. F of a plus h is 1 minus 4 times a plus h minus f of a, which is 1 minus 4a, all over h. And so now let's simplify this and we can see what we get. So let's distribute the -4 and we'll distribute the negative there. So 1 minus 4a minus 4h minus 1 and then plus 4a all over h. Now, if you do these right, the terms without an h in the numerator will cancel each other out. So 1 and -1 cancel each other out. 4a and negative 4a and positive 4a cancel each other out. So now we just have -4h over h. The h's cancel, and we just have -4. And look at that. It is the slope of the linear function, and that's not a coincidence. So really, if you have a linear function here, so the y equals mx plus b, x does not have an exponent, the difference quotient will be the slope, because that's what the difference quotient is finding. And if you think about this being a linear function, so it would look something like that. Anytime that you have 2 points, it's just going to be the slope of the line between those 2 points because it's not changing. So, so the difference quotient will always give you back the slope of the linear equation, if that's, or the function, if that's what we're looking at. All right, so in this case, we have a quadratic, and a quadratic is not as simple as a linear function. So quadratics, in this case, would look something like that. So this is not linear because we have this x squared. So let's do the same thing here. So f of a is 7a squared plus 6. F of a plus h would be 7 times a plus h squared plus 6. And I think we'll go ahead and multiply this out. So you can work this out the way we did the one a minute ago. But a plus h squared would be a squared plus 2ah plus h squared. And we have our plus 6, and we'll distribute the 7. So that'd be 7a squared plus 14ah plus 7h squared plus 6. All right, and now we're going to find the difference quotient. So f of a plus h minus f of a all over h. So f of a plus h will be all of this, 7a squared plus 14ah plus 7h squared plus 6 all over h. And then, well, the whole thing, we'll forget the next part. Minus f of a, says minus 7a squared plus 6. And all of this is over the h. All right, so now let's simplify our terms. And again, remember what I said, this still applies. Any term without an h should cancel out. And you can see that this one does. So 7a squared and negative 7a squared, and then 6 and negative 6, those cancel out. So we really just have the 14ah plus 7h squared over h. We can factor out an h from the top. So h times 14a plus 7h over h. The h's cancel. And we get 14a plus 7h as our difference quotient. Okay, so this one is a little bit more algebra. You definitely have to be careful when you're working this one out. The last one, maybe be careful, but you should know what the answer is going to be. This one, the answer is not as obvious. But again, this you will see this idea more in calculus, so it's a good idea to kind of familiarize yourself. Maybe not so much with calculating the difference quotient, at least looking at the calculus, but just understanding the idea of the difference quotient, how it relates to slope, and not just the slope of a linear function, but the slope of any type of function. All right, so another one with difference quotient. So f of a would be a over a plus 4. And then f of a plus h would be a plus h over a plus h plus 4. So here is the first x. Here is the next x plus 4. All right, nothing really to simplify there. So let's get our difference quotient. F of a plus h minus f of a all over h. So f of a plus h is a plus h over a plus h plus 4 minus f of a all over h. Okay, so now we need a common denominator. And so that's just going to be basically kind of cross multiplying, multiplying the a plus 4 times this numerator, multiplying the a plus h plus 4 times this numerator. And then our common denominator will be actually all of these put together. So let's see what happens. So we have a plus h times a plus 4 minus a times a plus h plus 4. And that is all over h times a plus h plus 4 times a plus 4. And so now we FOIL this one out. So we get a squared plus 4a plus ah plus 4h. Distribute the negative a, so minus a squared minus ah minus 4a all over h times a plus h plus 4 over a plus 4. And let's see what cancels. So the a squareds cancel and the 4a cancels. Actually, the h cancels. And so we have 4h on top all over h times a plus h plus 4 times a plus 4. And then the h's cancel. So we only have the 4 left on top, and then a plus h plus 4 times a plus 4 on the bottom. And there we go. So you can see these can get a little bit involved as far as the algebra goes. So it's important that you know how to set these up. Make sure you can get to this step pretty easily. And then after that, it's really just making sure your algebra skills are up to par. The easier algebra skills will be, the easier a lot of this course will be. So make sure you know how to set it up, and then hopefully your algebra skills are where they should be for taking it from there. All right, so the rest of these, I think, are finding the domain of different functions. So whenever you're asked to find the domain of a function, there are kind of some rules that you can remember based on the type of function. So anytime you're doing these, you should always ask, what kind of function is this? What kind of function? And if you remember, if you can identify what kind of function it is, that will tell you how to find the domain as long as you know the rules. So what are the types of functions that we're going to look at? We're going to look at linear functions, quadratics, maybe cubics, square root functions, exponential functions, logarithm functions, and then this one, which is a rational function. So what kind of function is this? This is rational. And we know it's rational because we have a fraction. So the root of this word is ratio. Like a rational number is a ratio or a fraction. So anytime you have a rational whatever it is, we're basically talking about a fraction of whatever it is. So in this case, it's a rational function, which means it's a ratio of functions. So how do you find the domain of a rational function? Set the denominator equal to 0. Solve for x. That number, whatever x is not in the domain. Everything else is. So x minus 4 equals 0. So x equals 4, not in the domain. Everything else is. So you could either write this as simply x not equal to 4, or you could write this in interval notation. So think about if you have a number line. So here are all the real numbers, and here is 4. We are going to take out that one. And so that means that negative infinity to 4 is in the domain. And remember from algebra probably, the parentheses here means we're not including the 4. So if you put a bracket, so bracket like this would mean you are including the 4. This one means we are not including the 4. So we need to not include the 4 because it's not in the domain. Union 4 to infinity. So you can see now we have every real number except 4 because we're not including it in this. But every other real number we are including. So we're including all of these, kind of a little hole there, and then everything else. And so that's a good way to write it. Sometimes that might be acceptable. Just kind of depends on how it asks you to put the answer. But for a rational function, you set the denominator equal to 0, solve for x, and then whatever you find that is not in the domain, everything else is. All right, here we have another rational function. So what kind of function is this? This one is rational. So we are going to set the denominator equal to 0 again, and then solve for x. So we have x squared equals 4. Now be careful here, because a lot of people just want to say x equals 2. And x, of course, does equal 2, but it also equals -2. So x equals 2 and -2. And so these are not in the domain. And so if we want to look at a number line, so we have -2, we have 2. We are going to include everything except those two numbers. So this interval, so the domain would be -infinity to -2, parentheses, we're not including that. Union, now this middle interval would be -2 to 2, both in parentheses. Union, and then this interval would be 2 to infinity. And there you go. So anytime it's a rational function, set the domain equal to 0, solve for x, and then everything else is what's in the domain. All right, what type of function is this? This is a square root function. So for a square root function, set now this part under the radical, so the square root is called a radical. The part under the radical is called a radicand. So a radicand, set the radicand, which is t plus 1, greater than or equal to 0. So why do we do that? We are working with real numbers. And what kind of number can you not take the square root of? You cannot take the square root of a negative number and get a real number back. So we want whatever is under here to be greater than or equal to 0. So set the radicand greater than or equal to 0, solve for t in this case, or x as the case may be. And this is the domain. In this case, that tells you the domain. And with the rational function, it tells you what's not in the domain. This one tells you what is the domain. So we just have to say t plus 1 is greater than or equal to 0. Solve for t. So we get t greater than or equal to -1. And so writing this with interval notation, we are including the -1. So -1 would work. If you plug a -1, you get -1 plus 1 is 0. Square root of 0 is 0. So -1 does work, and that's why we have the equal part here, because it is okay to include that. So we're going to have a bracket -1 up to infinity, and that is our domain. Now, maybe we should have talked about domain a little bit before we even got to these. And we do talk about it in the lecture video, but the domain, remember, is just all the set of valid inputs. It's a set of all the inputs that you could use for the particular function that you're talking about. So in this case, invalid inputs would be inputs that would make there be a negative under the square root. That would not work. Valid inputs, it'd be non-negative, it'd be 0 or positive. All right, find the domain of this function. So this one's not a square root, so we have the fifth root. So this is a radical function, or actually, let's call it a root function. Root function, and the index is odd. So we have an odd index. So the index is that number that is outside the radical. So there is the index. If that is odd, there is no restriction on the domain, because you can take the cube root of a negative number. You can take the fifth root. So for instance, going with the fifth root, and you can check this in your calculator, the fifth root of -32 would be -2. So -2 to the fifth is -32. You cannot do that with an even one, because an even one has to always be positive. You can't take the fourth root of -32, or -16 would be better, but you can't do that. So, but with an odd, you can do this. You can take the fifth root of all real numbers. So odd index, the domain is all real numbers. Unless there's something else. But for a simple function like this, the domain would be all real numbers. If you get into something like you have the fifth root of t minus 4, and then you put like a t plus 1 in the denominator, now we have a rational function we also have to contend with, but we're not talking about that. If we're just talking about a fifth root, odd root, whatever the odd number is, the domain will be all real numbers. All right, so what about this one? So now we have a square root function. And then this tells us that we also have a rational function. So now we're doing two things. So we got to use both rules here. So for the root function, set greater than or equal to 0. Set the 4 plus x greater than or equal to 0. For the rational function, we're going to set that denominator equal to 0. So we got to do both of these things. So 4 plus x greater than or equal to 0. So x is greater than or equal to negative 4. 2 minus x equals 0. We get x equals 2. And so this one is not in the domain. So remember, with the rational functions, the number that you find from solving that equation, that one's not in the domain. So all of these numbers are, except for 2. So here we have negative 4. Here we have 2. We are not including 2. So we're going to put an open circle there to not include it. Greater than or equal. So we're including every number greater than or equal to negative 4 except 2. 2 is not going to be included. So the domain would be bracket, because we're including the negative 4. Negative 4 at the 2 of the parentheses, and then union 2 up to infinity with the parentheses. And there is our domain. So in this case, we're kind of combining two types of functions. So you have to consider both rules. And then wherever the overlap is, that's what's in the domain. So the overlap gives you the domain. All right, and then the last one, find the domain. So this one is a square root function. So we are going to set this as greater than or equal to 0. Now this one is a little bit advanced for where we're at in this class, but that's okay. We can figure this out. So let's factor this. So this will factor as x minus 5 and x plus 2. Now we're not going to worry about the greater than, because when it's nonlinear, it gets a little bit more complicated than just keeping the greater than and then flipping it if you're dividing or multiplying by a negative. So that's kind of the rule with the linear inequality. With nonlinear inequalities, it gets a little bit trickier. So let's just solve this for x. So we get x equals 5, x equals negative 2. Now there are a couple of things you can do at this point. We have not talked about graphs of quadratics, although you probably have seen those before. But let's look at this. So we know that at these points, this function is going to be 0. So we know that these two numbers are in the domain. But what we don't know is, are we going to include this section, or this section? So what about the numbers between and outside of -2 and 5? So the way we can do this, and again, this is something that you'll need to really learn how to do for calculus. This is a good preparation for calculus. And what we're doing here is we're looking at test intervals. So negative infinity to -2, -2 to 5. And it doesn't really matter if you do brackets or not. That's not the point. what we're doing is we're going to look at every or a number in each of these intervals and see if they would work. So what we're looking for, if we plug in a number, so pick any number in this interval. So just pick an easy one like -3. So what is, oh, yeah, we're looking at x. So g of -3. And let's not worry about the square root, but actually, let's not even write g of -3, just so we don't get confused. Plug in -3 for the x. So -3 squared minus 3 times -3 minus 10. That gives us 9 plus 9 minus 10. So that is greater than 0. So x equals -3 means that g of x is greater than 0. So we are greater than 0 in this interval. So any other number that you pick -5, -10, -1,000, those will all be positive. Doesn't matter what you pick as long as it's in that interval. All right, same thing here. Now pick the easy one. So we'll pick 0. So x equals 0. You can see this one's going to be -10. So if you plug in 0 for x, you get -10. So that means that g of x is less than 0 on that interval. So that one is negative. And then pick any number in this interval, x equals 10. So let's see, we have 10 squared minus 3 times 10 minus 10. So that'd be 100 minus 30 minus 10. That's going to be positive. So g of x is positive there. All right, so now, since we want this to be positive, we're looking for the intervals where we get something positive. It doesn't really matter. We didn't take the square root because if what's under the square root is positive, the square root will also be positive. So the domain is the two intervals where we found positive numbers. So -infinity to -2. We're including that because -2 gives us a 0, which is okay. And then skipping this one because these are all negatives, which we don't want. And then going 5 to infinity. And there is our domain. All right, so very, very thorough homework. If you do these, then you're going to get different numbers, of course. But you at least can see kind of the way to do these. So, and the more you practice, the better, the easier these will get. But you want to kind of learn, you want to get to the point where you don't have to think about, for finding the domain, what do we do? Like you don't just want to guess all real numbers because as you can see, none of these, I don't think any of these were all real numbers. One of them was, but most of them aren't. So just guessing all real numbers is not a good strategy, and you're probably not going to be able to get, if you have no idea how to do it, you're not going to be able to guess. So the more you practice this, the easier we'll get. You really want to get to where it's kind of reactionary and you can do this without thinking too much. All right, so we'll see you on the next one.